Hi, today I'm going to show how we leverage TSL synthesis to automatically generate Python code, which we then use to control the motion of a self-driving car in Color. Color is a simulator which is used for self-driving car research. And for those of you who are not familiar with TSL, TSL is short for Temporal Stream Logic. It's a logical system which uses rules that are propositions of time. Words like always, eventually, and until are common drivers of TSL. Temporal stream logic allows for separation of control and data. That means you can write high-level specifications for any logical system that you want without worrying about handling data for a specific instance of the environment. All you need to do is to write out a set of rules for that environment. And then a synthesis tool can then be used to translate that TSL specification into code. You can translate it into Python code, JavaScript code, or Java code. We then leave code generation to the synthesis tool. So, for example, in this case, we used TSL synthesis to write to generate this code that we then use to control the motion of the self-driving car. So, this is the code that we generated using TSL. So, sometimes you find yourself wanting to write thousands of lines of code. So, because TSL is easy to use and it's intuitive, you can just write 10 lines of code in TSL, and then that produces thousands of lines of Python code. So it makes things easy. So I'm going to show you the TSL specification that I wrote to generate this Python code. So this is the specification that I wrote. I'm going to use the TSL synthesis tool to generate Python code. So we have two main components of the TSL specification. We have the always assume block and the always guarantee block. So in the always assume block, that's where we state our assumptions. We assume that at a certain point in time, we're going to get to a point where the red light is green, and we're going to get to a point where we reach an intersection. And then in the always guarantee block, we're going to state the behavior that we want our car to exhibit if we reach, for example, a red light or an intersection. So here we're saying if we reach a red light, we need to update control to stop so that the vehicle will immediately stop. And if we reach an intersection, we update the control to intersection. So we want the vehicle to exhibit intersection behavior. Otherwise, we just set the updated control to normal. So I'm going to produce Python code. So yeah, code is outputted here. So as you can see, we have some things like this. The W, we don't want this W. It was supposed to be a parameter that we pass in. For example, uh, self.red light ahead W. It means the world that the car is traveling in, or whatever town the car is traveling in. So when we produce the Python code, there are things like this which we do not want because it's not in parentheses. It's gonna cause some problems. So what I did to correct that, I wrote a program which removes things like this, sort of like a code cleaning process, an automatic code cleaning process. So I then copied this code and paste it here. So this is what I meant. The W is not a parameter, so it's causing problems. And we also have unbalanced parentheses. So in order to correct that, I wrote a search and replace program. Okay, so this is supposed to be this code is supposed to be under a function. So in the search and replace program, I added a function definition, and I also added these lines of code. What these lines of code is that what they do is that they replace a W with an empty quote, and then words like normal with parentheses, they're supposed to be strings and not functions. The only reason we wrote this as a function when we're writing TSL specification is because if we write it as a string, the TSL synthesis 2 doesn't accept strings at this time. So I had to write it using parentheses, and then I replace the parentheses with an empty string as well. So if I run the search and replace program, I'll run the terminal. Run search. Replace. So we've corrected everything. So now that we have corrected everything, this code, the my function code, is going to get code in the behavior agent. I'm not going to go into the details of how this code works. All I wanted to show is that TSL synthesis can be used to simplify the code writing process. So yeah, so this code now is going to be used to control the motion of a self-driving car. I'm going to run the file, the main.py file, which is the one used to actually start the vehicle. So main.py. So we specified that the vehicle should stop at a red light, and we didn't specify all the little details of how it's supposed to do that. The TSL synthesis generates all the possibilities, and it takes care of every scenario that's going to be considered. For example, if when the light turns green, we do not need to specify what happens. All we needed to specify was that it should stop at a red light. Otherwise, it should continue moving. So this program is going to run for 180 seconds, and then it's going to destroy all the actors. So it reaches an intersection. We expect it to exhibit intersection behavior, which means it should stop and look out for other vehicles and look at the traffic lights. As of now, there are no other vehicles, but the most important thing is to look at the traffic lights, and as soon as they turn green, it's supposed to continue its motion. So as you can see here, um, we didn't specify when it should stop. All we did is that we specified that at a certain point in time, we're going to reach a certain point in time where the red light turns red. I mean, the light turns red, and we're going to reach a certain point in time where the car reaches an intersection. And then in the guarantee, always guarantee block, we specify the behavior that we want the car to show. And then the TSL synthesis 2, it does the rest for us, like producing all these conditions. For example, if there's no red light ahead and there's no and the car is not at an intersection, the updated control is set to normal, but we didn't specify that. So it considered all the other possibilities, the TSLs in the system. And all we need to do is just write a high level specification. So this demonstrates how TSL can ultimately be a more intuitive language to learn and create logical systems with. Thank you.